Okay, so make sure on number 3, if you did number 3 by now, that you incorporate the 0. Why do I have to have a 0 right here? It's a placeholder for what term? X squared. It went from x cubed to x's. You have to have 0x squareds in the problem. It is there. It's hiding. Okay? So 0x squared is part of your, what's that called? Dividend. Thank you. There's a worksheet over there. All right. So you have to have a 0 there. Otherwise, it doesn't work. You have to have x cubes, then x squareds, then x's, then constants. Okay? So redo that one if you accidentally messed that one up. Not a big deal. That's why we're learning it, right? Okay, when you do that, you bring the first one down, and then you multiply, add, multiply, add, multiply, add, till you get to the remainder box. Is that okay? Yes, ma'am.
Sorry, can you explain one more time the 0 thing? I still
Okay, look at your dividend. What's the first degree?
3.
So you have to have a second degree next. Then you have to have a first degree next. Then you have to have the 0 degree, which is a constant, last. So you always go from the highest degree down.
Okay.
Is that okay? All right. So this is x cubed. That means this is x squared. That means this is x. That means this is... Is that all right?
Yeah.
Okay. All right. Do we have time for 3? Looking at that now? All right. Double check 4. Make sure you don't need anything for 4. Okay. So let's look at 4 now. Here's my answer for 4. Hopefully you're getting the same answer for 4. I had x cubed, so that's one of them. I had x squared, negative 5. What's my 0 placeholder this time? I have 0 x's. I hope you put 0 there. And then I had negative 2. And then I'm dividing with x equaling 4. So now again, I bring the first digit down, and now I start multiply, add, right? So I'm going to multiply, I get 1 times 4. That's 4. Add them up. Get negative 1. Multiply, I get negative 4. Add them up. Multiply, I get negative 16, add them up, and my remainder is negative 18, so I can write it this way, okay? All right, so 2 questions. Factor theorem. Is x minus 4 a factor of x cubed minus 5x squared minus 2? No. What is the value of f of 4 in this equation? F of 4 equals negative 18. If you ever see f of 4, that means plugging in 4. In other words, by the way, also I could do this just so you can see some different ways to understand this. Watch this. If I plug in negative 4 into my original equation as x, that would mean this, right? 4 cubed, oops, can't see it. 4 cubed minus 5 times 4 squared minus 2. Does that make sense? I'm taking all these x terms and I'm plugging in 4 right there. Does that make sense? If I hit enter, what should I see? Negative 18. Boom, there it is. Okay? So it still works the same. All right, so now we're going to do something slightly different. And on these new ones, we're going to have a coefficient in front of the x term. So we look at number 5. How is 5 slightly different? It's got a 2x. Now, is this still linear? Yes, because it's x to the power of 1. It's a degree of 1. So we're going to do the same exact idea, okay, only we're going to first figure out what we divide with. So if 2x minus 5 is our 0, it means we set it equal to 0. And we solve for x. So what does x equal? Leave it as a fraction. Don't do decimals. 5 over 2. Because you add 5, then you divide it by 2. So what we're going to do is we're going to use 5 halves as our 0 that we divide synthetically with. So we're going to write 5 over 2. It's not wrong to do it as a decimal, but you're going to have to re-encode your answer later. Anytime you have decimals, you don't write factors with decimals. You don't write like x plus 2.5. You would write it as 2x minus 5. So you have to know how to re-encode this, okay? All right, we're going to put our, what are these called? Coefficients, and note any 0 placeholders if we need them. We're going to start with 2x to the 4th minus 5x cubed minus 8x squared plus 4x minus 12. And this is great. We don't need any placeholders of 0. And we put a little box under the last digit, under the constant, for a remainder box. You okay with what's going on? It's pretty straightforward. All right, we start by bringing down the 2, and try to do these without a calculator because you're going to have to do them without a calculator on your test most likely. Synthetic division is usually a non-calc part. All right, and if you think of multiplying by a fraction, all this means here is 2 multiplied by 5 halves. So what I usually do is multiply by the numerator, divide by the denominator. It's 2 parts. It's times the top and divide by the bottom. That's it. So 2 times 5 is 10, divided by 2 is 5. There you go. Make sense? All right. Add up this row. What do I get? 0. This is great. I love when zeros happen because 0 times anything is still 0. Is that okay? All right. Then add up the next row. Negative 8 and 0 makes negative 8. I'm going to do the same thing. Negative 8 times 5 divided by 2. What do we get? Negative 20. By the way, sometimes if these numbers get really big, like in the next row, I'm going to show you a little trick that you can do backwards because PEMDAS, multiply and divide, can be any order. It doesn't have to be multiply first, then divide. Multiply and divide happen as a group. So in this column, I get negative 16. And I'm not quite as fast as what negative 16 times 5 is. Maybe you are. I'm not. But I am definitely fast at negative 16 divided by 2. What's that? Negative 8. So if I divide first, I made this smaller, and then I multiply it by 5. It doesn't matter the order. So negative 8 times 5, that makes a negative 40 there. So sometimes I divide before I multiply, as long as it's in the same group. All right? All right, this makes a negative 52, so that's my solution. When x is 5 halves, y is negative 52, according to the remainder theorem. But I'm trying to find the quotient here, so I got to recode this. What does this 2 represent for our answer? Good, it's always 1 degree less than what you started. So this is x cubed. This is x squared. I have none of them, so I don't even have to write it. This is minus 8x's. This is minus 16, and this is my remainder, so I always put plus whatever my remainder is out of what I divided with. Okay? Now, if you write it this way, you're actually wrong. Okay? In this particular problem, this is why this is slightly different. In this particular problem, this is not the correct answer. This is the correct remainder. The remainder doesn't change. But this right here is not actually correct. Let me show you something on why. Okay? If I do long division, 2x minus 5, we're not wrong. We have to incorporate one extra step. Okay? If I do this, all right, I want 2x into 2x to the 4th, which means my answer is x cubed by itself. And when I multiply here, let's see, I'm going to get 2x4 minus 15x third. I subtract these, that cancels. This is going to give me 10x cubed. Make sure my math is right. Sometimes I accidentally mess up. I do it all over again, and I get 5x squared. Okay, this becomes 10x cubed minus 25x squared. Am I okay? If I add that, that's going to be, what is that, 17? Then I'm going to get, no, I did something wrong. 5 times 2 is 10. 5 times 5 is negative 25. I'm adding, oh, this is 16. No, it's 17. Where we mess up, guys? I shouldn't get a fraction here. Did I write it down right? X cubed. Oh, this is why. 5 times x is just 5x. This becomes 0. We all missed it. The whole class missed it. How dare you? No worries. Here's how we fix things. You just cover them up. Alright. There you go. This is like many of the greatest mathematicians in the world. They just did this. And then they discovered something like Pythagorean theorem. They didn't even have whiteout back then. Alright, so this is 0x cubes. Or, sorry, this multiplies out to make 0x cubes. So we just bring these guys down. And now I get minus 4x. So this becomes minus 8x squared and plus 20x's. When I subtract this row, they cancel. This becomes negative 16x. Bring down the negative 12. I multiply, I get minus 8. This becomes negative 16x. This becomes plus 40. When I subtract, I get negative 52. That's great, because that was my remainder from before, right? Is that okay? Sorry, I took a little extra time. Look at our quotient, though. X cubed minus 4x is minus 8, and look what our quotient was. 2x cubes minus 4x is minus 8. What do you notice about our synthetic answer compared to the actual long division answer? What do you notice? It's exactly, this is exactly half of that, or that's twice as much. And here's why it happened. Because we took our answer and we divided it by 2. Make sense? And the reason is because of this 2 in front. So when you do synthetic division with an a value on your linear term, when you get your solution, what you actually have to do is divide everything by that denominator. We're going to divide everything by 2, and that's our correct answer. And the reason is because in order to get 2x minus 5 from 5 halves, right here, you're going to have to multiply by 2, which means you're going to have to double this. And if you double one thing in a factor, you got to half the other thing in a factor, so that the answer is still the same. Okay? So our real answer is x cubed minus 4x squared minus 8, minus 8, and then the remainder doesn't change. And the reason is because we had to divide that by 2. Okay? So if I look at number 6, I'm going to first figure out what my x value is. My x value is x equals what? 2 over 3. Now, when we get our answer, what are we going to divide it by? We're going to divide our answer this time by 3 at the end when we're done. So let's see if we can get that correct solution this time. We're going to write 2 over 3 on the side. We're going to do our synthetic division bar. 3, 1, 1, negative 2, and put our box under our remainder. Now, I don't need any zeros here because it's x cubed, x squared, x, and constant. Everybody okay with what's going on? How do I start? Bring down the first digit. In this case, it's a 3. Okay? 3 multiplied by 2/3. Well, 3 times 2 is 6. Divided by 3 is 2. Add up the column. That's another 3. 3 times 2 is 6. Divided by 3 is 2. Is that okay? Add up the column. 3 times 2 is 6. Divided by 3 is another 2. And this time I get a remainder of 0, which is nice. But since I'm having a factor of divided by 3, I'm going to divide everything by 3. And this is really going to turn into 1, 1, and 1. Now I got to recode my answer. This is 1 what? This is going to be x squared plus 1x plus 1. There is my correct solution. Okay?